Here is a sample of a radioactive material or isotope. And you can see the nuclei surrounded by the electrons, and at some point every single one of these nuclei, because it's radioactive, will decay by emitting either alpha, beta, or gamma radiation. Now this process of radioactive decay is random. Now that means that we don't know when any particular one of these is going to decay and become stable. But different materials will decay at different rates on average. So if you've got a lot of atoms together, then we can start to measure how quickly it decays. So first of all, let's talk about something called activity. And the activity of a radioactive material is the number of decays happening per second. So it's the number of nuclei that decay on average per second. So if you have an activity of on average 50 nuclei per second, then it won't be long till this sample has completely decayed. The actual process can vary from material to material. Some materials may take thousands of years before the nuclei completely decay. In fact, some of them take millions of years. So how could we measure this? Well, we use a device called a GM tube or a Geiger-Müller tube. GM tube. And a GM tube, when one of these nuclei decay, let's say that this one decays and it spits out an alpha particle, that GM tube will pick up the alpha particle and will count, send a pulse to a counter, and then we know that one of those nuclei has decayed. Now we only manage to pick up a certain proportion that enter through the window of the GM tube, but it gives us an indication, and this measure is called count rate, usually in counts per minute. Counts per minute. The count rate depends on how many nuclei you've got remaining, how many undecayed nuclei. And you can think of these, imagine you've got, all these are dice, and if you throw them on the table, then if you get a 6 being thrown, then let's say that the dice decays, the nucleus decays. And if you've got a lot of dice remaining, then you're going to get a lot of 6s being thrown, and a lot of them will be decayed. We'd then take those dice away and would throw it again. You've got fewer remaining, so you'd get fewer 6s. So that's count rate. And another measure of the decay of a material is something called half-life. Now, as time ticks on, let's say that half of these decay. How many have we got? 1, 2, 3, 4, 5, 6, 7, 8 by 4, 32. So we're looking for about 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these have all decayed. And the time taken for this half of these nuclei to decay is called the half-life. And it's the average time because it depends, it's a random process, so you're not going to get it exact. So let's go to this flashcard to investigate the half-life of a material. The half-life of a radioactive isotope is the average time it takes for half the number of nuclei to decay, to become stable. And you can also measure half-life by, it's the average time taken for a sample's count rate to halve. Similar idea. Now we can calculate half-life if we have a graph of count rate per minute versus time. Or if this axis here was the number of nuclei remaining, the number of undecayed nuclei remaining, you'd get a very similar curve. So let's do a calculation, but we're going to use count rate. So to calculate the half-life, start at the initial count rate, which this Geiger-Müller tube is detecting 100 counts per minute from this sample. There we are, up here. And what's the time taken for it to halve from 100 counts per minute to 50? Well, we take a ruler and rule across and rule down, and we see that the time is from 0 to 4, so it's 4 hours. 4 hours. Now that time should be the same if we start at 50. If we started at 50 and halve 50 to get to 25. What's the time taken? Well, we're going to rule across from 25 and then we hit 8. And so the time taken to get from 50 counts per minute to 25 counts per minute is from 4 to 8. Again, 4 hours. And that's the half-life. It's always going to be the same, no matter where you start from. If you started from 80 to 40, it would be the same time. So that's how you measure half-life of a radioactive material.